Hi all, we are Group 9 and today we'll be presenting our final project titled Sleep, Health and Lifestyle. We chose this topic because we were curious about how sleep, gender, lifestyle factors and health are connected. We came across a few interesting studies. One from the European Journal of Public Health saying women sleep more than men. One from the US Centers for Disease Control and Prevention (CDC) linking exercise to lower blood pressure. And another from UT Southwestern Medical Center saying poor sleep can lead to weight gain. These inspired our research objectives and hypotheses. Our first objective is to explore the variability in the sleeping duration between male and female working adults. We treated sleeping duration as discrete data. From the bar chart, we can see that male sleep durations are more concentrated in the 7 to 8 hours range, with 47 males in that group alone, showing lower variability. In contrast, females are more spread out across different sleep ranges, especially in the 6 to 7 and 8 to 9 hours intervals, suggesting higher variance in their sleep duration.
Graph 2 shows the systolic blood pressure of 150 working adults. The objective of this graph is to explore whether high physical activity is linked to lower blood pressure among working adults. There is no significant difference in the mean of systolic blood pressure between working adults who exercise for less than 50 minutes and those who exercise 50 minutes and more per day. The graph shows that both data are negatively skewed. This graph shows the normal and obese overweight. The objective of this graph is to investigate whether elevated body weights are associated with risk of developing sleep disorders like insomnia and sleep apnea among working adults. The analysis found from this graph are obese or overweight working adults are significantly more likely to suffer from insomnia and sleep apnea, while those with normal weight more often report no sleep disorder.
Hypothesis testing 1. The first hypothesis testing is there is no significant difference in the variance of the sleeping duration between male and female working adults. Females and males are considered two independent populations. The null hypothesis is sigma square 1 equals to sigma square 2. The alternative hypothesis is sigma square 1 is not equals to sigma square 2. Since we are comparing variance of two populations, we need to use the F-test with 95% of confidence level. Thus, the significance level that we will be using is alpha equals to 0.05. We will be substituting the variances into the formula. Next, to find the critical value, we will be finding the degrees of freedom. Then we will substitute that into the formula of upper critical value and lower critical value. Since f calculated, which is 1.684, is more than the upper critical value, which is 1.48, it falls in rejection area. Thus, we reject the null hypothesis. Therefore, at the significant value alpha equals to 0.05, there is enough evidence to support that there is a significant difference in the variance of sleep duration between male and female working adults. Based on the confidence interval, the variance of females is higher than the variance of males, since the confidence interval is greater than 1. Thus, this supports the conclusion.
For hypothesis testing 2, we will be testing on working adults who exercise for 50 minutes or more a day have an average blood pressure lower than those who exercise less than 50 minutes a day. The null hypothesis for this is mu1 minus mu2 equals to 0, while alternative hypothesis is mu1 minus mu2 greater than 0. From the data, we can obtain sample mean, sample size, and sample deviation for those who exercise less than 50 and for those who exercise 50 or more. These are the data. Since n greater equals to 50, 30, we need to use the z distribution even though the popular variance is unknown. A 95% confidence level is used. It is a one-tailed test. We will be using the formula z equals to x bar 1 minus x bar 2 over square root of s1 square over n1 plus s2 square over n2, and we will get 0.19. As for alpha, significance level is 0.05. For the z critical, we will be using z distribution table. Hence, it is 1.645. Since z calculated is lesser than z critical, hence we will reject the null hypothesis. Based on the sample and significance level, there is no enough evidence to support that working adults who exercise 50 minutes or more a day have an average blood pressure lesser than those who exercise less than 50 minutes a day.
Next, the hypothesis testing 3 on more than 80% of overweight and obese working adults who suffer from sleep disorders like sleep apnea or insomnia. The null hypothesis is p less than equal to 0.8, while the alternative hypothesis is p greater than 0.8. First, we need to find the value of NP and NQ. The value of NP and NQ is greater than 5, and the sample proportion is approximately normally distributed. Therefore, we should use the z-test to find the test statistic. And we'll be using 95% confidence level. Thus, the significance level that we'll be using alpha is 0.05. P not equal to 0.8 and equal to 59. Obese and overweight people who have sleep disorder is 51. Thus, the p hat is 0.864. By using the formula, we can find the test statistic. The value of test statistic is 1.229. The critical Z value at alpha 0.05 is 1.65. Since Z calculator is less than the critical Z value, we fail to reject the null hypothesis. Therefore, there is not enough evidence to support that more than 80% of overweight and obese working adults suffer from sleep disorders like sleep apnea or insomnia.
Conclusion. To sum up, none of the three hypotheses were achieved. Based on the findings of this project, it concluded that there's a variability of sleep duration between male and female working adults. There is no significant connection between physical activity and blood pressure among working adults, and the relationship between body weight of working adults and sleep disorders such as sleep apnea or insomnia remains inconclusive because of the different results obtained in the hypothesis testing and analysis description. Thus, future studies should consider using a larger and more diverse sample size for more robust analysis.